All right, so this is the homework problem that was assigned. I set this part up for you. Somebody said they've already done this math right here. 2.50 divided by 30.0061. What answer did you get? 0.83. Is there more to it? 0.83316.
Yeah, 396.
Okay. Now, I have canceled all the units of grams and all the units of NO, or all the species of NO. So what I have left now are moles and NO here. Okay? So I'm going to put moles and NO on there because they belong there. Dick, how about join us here, okay? And I need to look at significant digits. Robbie, let's pay attention up here, please. How many significant digits should I have in this answer? Anybody, everybody, including Amber.
The last 4 digits.
Okay. All right. So where do I start underlining this answer? With the 1. Leading zeros are not significant. So now we round it off. 0. Moles of NO. 0.0833 moles of NO. Now what I said was that answer, whatever you got, was going to be plugged right in here. So this answer gets plugged into that. 0.0833. I even told you it was going to be moles of NO. And if you did it right, you should see it's moles of NO down here.
So that's what we have to do with when we get that equation, do that all type
Mm-hmm.
thing.
So this is moles of NO. Okay, we're plugging it in right there. Okay. And we put it over 1. All right. So that's what I told you we're going to do with it. And I explained where this fraction came from. It comes from the balanced equation. You have to have a balanced equation to this next step. And your balanced equation was right here. Okay. Where the moles of NO were 2. And the moles of oxygen was 1.
So you times the numbers by each other.
Now you use these as your molar amounts for your molar ratio.
Oh, so for it would be 2 over 1.
Oh, actually, I think it's 1 over 2. Okay. Because what we have. Well, let's look. Let's just do it this way. Let me go back to the equation. Okay. All right. So from the equation, then, the molar amount of NO is 2 moles. See that? Okay. So we'll put 2 moles of NO on the bottom because I'm trying to match the units and species.
Oh, so the amount of molar would be on the bottom.
Well, in this case, I don't have moles on top and bottom. But what I want to do is I need to make sure this step matches the units and species in the previous step. Yes? What? Because there's 2 moles of NO right here in the balanced equation. Okay, and how many moles of oxygen are there? 1. There's a coefficient of 1 implied right here. Okay, so that's 1 mole of O2. That makes sense? Your molar ratio comes from the coefficients in the balanced equation. Just like every conversion we've done so far, Dick, just like every conversion we've done so far, we always put on the bottom of the conversion fraction what matches the units and species of what came before it. Every time. We haven't done anything different all semester from the very first unit. We've always put on the bottom of this conversion fraction what matches the units and species in the previous step. And we're doing the same thing here. Okay? And now we have to do this math. Everybody do the math. Practice the math. Yes?
So, on the right-hand side, is it all going to be moles over moles?
This right here?
Yes.
In this step it is. But remember the previous step, the first calculation, was not moles over moles. It was moles over mass. Okay? So this is moles over moles. Alright? Because now what we're trying to do is to go from this species, NO, to this species, O2. And when you're going from one species to another, you have to have a molar ratio.
The
Why are
answer
we
is
going to
0.04165.
0.04 what?
4165, yeah.
4165 moles of O2. Okay? How many significant digits do we need in that answer?
You need to cut the 5 from 5 off.
Need to there you go. Need to underline the 5 and round it off.
Yeah,
0.0417, okay, moles of O2. And that's that answer.
Okay.
Okay? We're not done yet because there's a third step down here. I said that answer you're going to calculate, and we just did it right here. That answer then becomes this, goes into this part.
This is all one problem.
All going to be, yes, one problem.
Well, when you give us these problems on test, we already have to set up this, and then we can figure it out.
No, I'm teaching you how to figure it out.
Mr. Tanner,
Yes, Amber.
why are you trying to go from NO to O2? Like, what's the reason?
Stoichiometry. All right, stoichiometry. This is one of the basics of chemistry. Stoichiometry.
So we got like that's the reason because it's stoichiometry?
No, because it's one of the basics of chemistry. In any industrial application of chemistry, one of the first things you need to be able to do is stoichiometry. If I am doing a manufacturing process of any kind that involves chemicals, I need to know how much of this chemical do I need to do what I want to do. This is the math for doing that kind of, or the beginning of that math.
So you're going to go to O2.
That's what we're doing here. Okay? This is basic chemistry. Basic chemistry. Huh?
So CP is basic chemistry?
No, not in that sense. I mean, there's a lower level chemistry than this.
Well, I want to go with them, but they didn't let me.
All right, now this becomes our new starting amount. We're going to put that over 1, 0.0417 moles of O2. And we want to get it into a form we can measure. You cannot measure moles. Okay, you have to measure it in grams. And so what we need to do now is to convert moles to grams. So what do I need? What kind of conversion do I need to get from moles to grams? Huh? Well, what do you call that when you calculate? What do you got to calculate? You have to calculate the molar mass. That's what we did in the first step, was calculate the molar mass. Calculate the molar mass, then everybody calculate the molar mass of oxygen. Calculate the molar mass of oxygen and put it on your paper. Calculate the molar mass of oxygen. We've been doing it for a week. Yes, Alec?
So we were using the NO to have the common species. Then we got your answer. How come you put O2 as the species?
Because I'm trying to find out the answer to this problem. If you start with this many grams of nitrogen oxide, okay? So the problem asks you to find the amount of the other species. That's what we're doing.
take.
No, we're trying to find the mass of oxygen now.
I got it.
I know, but I'm waiting for everybody else to put it down on their paper, including Dick and Robbie. Put it down on your paper. The molar mass calculation. Do the work. Show me your molar mass calculation. Yeah. Got your molar mass done, Manuel? What? William, we're doing some work here. You got your molar mass calculated? Huh? Nah. Thank you. I appreciate you being honest. Let's get it done. Do it the right way. Do it the way I taught you. And I've been going over and over and over it for a week. You got yours done, Amber?
No, I need to find him.
Amber, you come to my class and it's how far we in? You can't find a pencil? Almost half an hour you've been in here.
Oh, there. Oh, 31.998.
Good, I can hear you. I heard you. Thank you. All right.
Mr. Taylor, how many students have passed through? Yeah, I know. No, my main goal is to pass with me.
Please pay attention and listen. That's a classic question for another time. Let's stay with chemistry. Oh,
I ain't worried about that.
okay.
When it comes to this, you just take the oxygen and then you divide it by mole of oxygen. Like you take.
Oh, over here?
Yeah, you take your 0.0417 and then divide it to what you get from that when you combine the oxygen together to get that.
If I'm not sure if the way you stated, I'm not sure I can say yes or no. All right, hold on. I'm going to go through it. Just be patient. I need everybody to be quiet and listen. I need everybody to be quiet and listen. All right. This is what I have to see if you expect to get points for calculating molar mass. You need to do the whole thing.
In your format, right here.
You need to write all, when you're done, when you add them up in this way, and you're going to put down here that you have a mass, grams of O2 equals 1 mole of O2 when you finish this calculation. Now in this case, there were no empty slots to the right, so we didn't have to round off. Remember, you have to round off if you got any empty slots to the right. Okay? This is an equality statement. One value equals another value. I can use that then to build a conversion unit. I want to choose the side of the equality statement that matches what I had in the previous step and put that side on the bottom. Please do that on your paper. The side of the equality statement that matches the units and species in this step, you're going to put on the bottom here. Please do that.
Put the 1 mole of O2.
Choose the side of this equality statement that matches the units and species in the previous step and put it on the bottom. Okay, yes, you can put 1 mole of O2 on the bottom. But if that's all you know to do is, I say do that, you do it, you're not going to be able to solve it on the test. I know you're not, but somebody else spoke up to tell you exactly what to do, and I'm trying to make the point that you need to understand the process. You and anybody else. It wasn't you particularly, okay?